So if we want to find the arc length of a curve, just how long this line is, then we can start by dividing the curve into infinitely small segments. And if we make each of these segments, which we'll call ds, if we make them small enough, then we can approximate them as a straight line. And we can say that this straight line is the hypotenuse of a right triangle. And the sides of that triangle will be a very small change in x and a very small change in y. So finding the length of the hypotenuse of a right triangle is easy. So we can find the length of each of these infinitely small segments and then add them up throughout the whole curve to find the length of the whole curve. So by the Pythagorean theorem, ds squared, the length of each of these segments is going to be equal to dx squared plus dy squared. And then if we divide both sides of this equation by dx squared, and then take the square root, and then move the dx over to this side, now we have an equation, because if we integrate ds, that just means add up all the ds, add up all the lengths of the small segments of this arc. So if we add up all of the lengths, then we just get the length of the whole arc, which is what we're looking for. So all we have to do is integrate both sides of this expression. So if we want to find the arc length from x equals a to x equals b, then we just take the square root of 1 plus the derivative dy dx squared times dx, and then integrate that from a to b. And that'll be the arc length. So if we want to find the length of this curve, which is just a line from 0 to 2, first I like to find the derivative, which is 5, and then square the derivative, which is 25, and then plug that into the formula. So we have the integral from 0 to 2 of the square root of 1 plus dy dx squared, which is 25. So that's just the square root of 26, which integrates to the square root 26x, because it's just a constant. So the limits are from 0 to 2. So we have 2 square root 26 minus 0 square root 26, or just 2 square root 26. So that's the length of this line from 0 to 2. Now we can also calculate arc length with respect to y. So the formula is almost the same. The only differences are our limits a and b will be y values instead of x values. And instead of dy dx squared, we have dx dy squared. And then of course we have the dy instead of dx. So we can find the length of the same curve that we just found using y this time. So we need our new limits of integration, since we need y values instead of x values. So at x equals 0, the y value is negative 2, and at x equals 2, the y value is 8. So a new limit will be from negative 2 to 8. And then we need to rewrite the function as a function of y. So solving for x, we get x equals 1/5 y plus 2/5. Now we can differentiate to find that dx dy is 1/5, and dx dy squared is 1 over 25. So plugging these into the formula for the arc length with respect to y, we can solve the integral, and as you can see, we get the exact same answer. So it doesn't matter if you integrate with respect to x or y, you just do whichever one is easier.